And then I should say, if you ever have a question, comment, or concern, never hesitate to email me. That's the best way to get hold of me, and I'm pretty good about answering that. So let me know, and I'll try to help you as much as I can. Okay. All right. So let's actually look at some math. Here's a problem. I hope you can see it out there in the digital world. Let's see what I'm looking at. Yeah, you should be able to see it. Okay. Okay. I'll try to explain some content and problems at the same time. All right, what are we looking at here? We got x over 6 plus 1/2 plus 5 over 12. Well, believe it or not, this is a line. This really is just a line. What line is that? That's just y equals mx plus b. Okay, and everyone remembers y equals mx plus b from high school. Okay, so that's what we're looking at. But it doesn't look like that, right? It looks like x over 6 plus 1/2. There's no y, there's nothing like that. So that's kind of strange. But here we want to solve for x. Okay, so we want to solve for x in this expression. So we have to remember, how do we do this? How do we solve for x? How do you solve for a variable? Well, the way you want to solve for a variable is you want to get it by itself. Okay, you want to get x by itself. How do you get x by yourself? Well, I've just seen this in the chat. Do you have to create a Pearson account to access the math assignments? No, you should just go to IB Plus in our course website. Just go to IB Plus and it will do everything for you. Okay? Hopefully you caught that, Matthew. All right. So solve for x. How do you do that? Well, you got to get x by itself. How are we going to get this x by itself? Well, what I'm going to do is I'm going to kind of do PEMDAS in a way. You guys probably remember PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. Multiplication and division are equal, and addition and subtraction, the order doesn't matter for those. But that's what we want to do. We want to get x by itself. How do you do that? Well, x over 6 plus 1/2 equals 5/12. What we need to do is we need to get this number on this side. That would be ideal. How do we do that? Well, this is being added, so I'm going to subtract. Okay, that will do what I need it to do. So if I do that, then I'll have x over 6 equals 5/12 minus 1/2. All right, now I have a fraction minus a fraction. So here's a review. How do you do arithmetic with fractions? So we have 5/12 minus 1/2. And the problem is those denominators, the numbers on the bottom, they're not the same. Your homework will have different numbers than the one I'm showing. Yes, we'll all have different numbers. Okay, so 5/12 minus 1/2. So we have different denominators. Well, we have to have the same denominator if we're going to add or subtract these. So I'm going to turn that 2 into a 12. Okay. All right, so how do I do that? So 5/12. And I want the 2 to be a 12. What did I need to multiply 2 by to get 12? I had to multiply by 6. Okay, so there we go. All right, so 5/12 minus 6/12. Well, 5 minus 6 is -1. It's -1/12. Okay. So far, so good. All right, almost done. What does that mean? That means that x over 6 equals -1/12. All right, last step. We need to get that 6 on the other side. How do I get that 6 on the other side? This 6 is dividing the x. So I think if we multiply both sides by 6, then we'll have it, okay? All right, so let's do that. We're going to multiply both sides by 6. So x equals negative 6/12. All right, now I need to reduce that fraction. Well, that would be 1/6 over 2/6. So that'd be negative 1/2. So I think that's the answer. X equals negative 1/2. We had a lot of review about fractions, order of operations, and everything in there. But that's why I think x equals negative 1/2. All right, hopefully that makes sense. Any questions, comments, or concerns about that one? Well, I'm going to clear the screen unless there's any questions. I probably won't have time to do every question, but I'm going to do at least the first chunk here. Okay, so we got x divided by negative 3 is less than 3/4. Now we have inequalities we're trying to remember. So it's not equals, it's just less than, So the left-hand side is less than the right-hand side. So that means there'll be infinite amount of x's that will work. We have to find where those are. Okay, so I remember when I first learned this, and I know you already learned this before, but I was taught, well, think about it first as if it was equals. Okay, that's a technique. Some people like that. So think about, if it was equals, what would you have to do to solve this? Well, I would just multiply both sides by that negative 3. So negative 3 times negative 3. And that would do it. So I would cross off here. That negative 3 would cancel. And then this would become 9. So x equals negative 9/4. If it was equals, that's what I would do. But it wasn't equals, so what do I do? All right. So I'm still wanting to multiply by negative 3. I think that's still the technique to go with. It's over negative 3 is less than 3/4 times negative 3. I still think that's the way to go. That reduces, okay? So then we have x by itself, and then 3 times negative 3 is negative 9/4. But with the inequality, what's strange is if you multiply or divide by a negative number, it flips the inequality, okay? In a more sophisticated way of thinking, you took the opposite. By multiplying both sides by a negative number, you're saying, I want the opposite. So with the inequality, this flipped, okay? So with inequalities, it flips. With negative numbers. And that's with multiplication or division, okay? Because in some sense, those are the same. That's kind of strange. You're coming back from another high school or something, they might teach that a little differently, but that's how I would do it, okay? So that's the idea. And then that's, this was a multiple choice, so I picked greater than, and then negative 9/4, I entered it. That's the idea. Okay, what if you were just totally lost? You had no idea. Well, you can view an example and they'll probably explain it differently, maybe better, maybe worse, but differently. So at least you'll get 2 points of view, and you can kind of go through here, and it looks like we did something similar. So you have that, that's nice. That comes with the course. You don't have to pay for that. And then on some, let's see, get more help. This one you can look at the textbook. So that's cool. So I can open the textbook, and they'll probably just send me to a general section here. Yeah, so you have the textbook, digital textbook there to explain inequalities in case you want to go back. So that's cool. And of course, you could always YouTube this. You look up inequalities on YouTube. Great videos on there too. And then there's always Ask My Instructor, which is just going to email me and you say, hey, I'm really stuck on problem 2 here. And I think it should be 9/4. X is greater than negative 9/4, but it's saying it's wrong. Can you help me? And I'll try to help you as soon as I can. So you got some help there. Okay, well, moving right along. Let's do 3. I'm going to show 3 today. All right. Let's see. This is just an algebra expression here. And we have 10x plus 24x minus, in parentheses, we're going to remember that PEMDAS, x minus 5 equals 254. We want to solve for x. Solve for x. That's what I'm going to try to do. Well, I'm going to start with distributing this 24. I think that's the first thing I have to do. PEMDAS. P for parentheses. PEMDAS. Remember, multiplication and division is the same. Addition and subtraction is the same. But we got to do those parentheses first, so let's do it. So we got 10x plus 24, x minus 5 equals 254. Okay, so let's distribute that 24. What happens when you do something like that? Distribution law, real numbers. Well, when I do that, I'll get 10x, that was already there, and then 24x. Now 24 is a coefficient of the variable. And then we want to do 24 times negative 5. All right, well, 2 times 5 is 100, and 4 times 5 is 20. So I think that's negative 120. Check my arithmetic, though. 254. Now we can start combining like terms. So I could put the 10x and the 24x together because they're the same. They're of the same order. Okay. So 10 and 24 would make 34x minus 120 equals 254. Okay, the whole point is we want to get x by itself. So we need some way to get x just isolated. How do you isolate x? Well, I'm going to get that 120 to the other side. Whatever number you get, want to get to the other side. How are we going to do that? In this case, we're going to add 120 to both sides. So it looks like it's 374. Okay, as long as I'm not making arithmetic mistakes, it's 34x equals 374. Okay, I got 34 x's equal 374. Well, how much is just 1x? And to do that, I'm going to need to divide both sides by that 34. Okay, well, let's see. So 34, 374. How many times can 34 go into 37 once? 34. That gives me a 30, and that gives me a 4, and that's 11. I like it. X must equal 11. Easy come, easy go. So this is just some review of algebra, maybe algebra 2, I don't know which one. Or maybe you had pre-calculus, would have seen something like that. But algebra, I think everything I've shown so far, I used to teach in my intro algebra course, so should be at least familiar. I mean, you might have to knock off some rust, but it should be familiar. All right. Let's see. That's not what I want. Step 5. Solve the inequality and determine the graph of the solution set. Okay. We got 5 is less than or equal to, that's what that symbol means, by the way. When it has the less than or the line underneath it, means it can also equal. We'll talk what that implication means in a moment. 9/5 C plus 32 is less than or equal to 68. This has to do with temperature. I think this has to do with converting temperature to Fahrenheit. I think that's what it is. But I don't think we have to know that to solve it. All right, so we want to know, what does C equal? Okay, what does C equal in this compound inequality? Well, you can teach it in a couple different ways. This one's easy enough. I think we'll just go straight forward. But you might have seen in high school or something, you can break it up into 2 pieces and solve each of those individually. And that's great, especially if you're going to do some complicated ones. This one's not too bad. I think we can just go straight forward. So that's the way I'm going to show it. So, you know, in the previous examples today, we have, you know, if we added something, we did it to both sides. If we multiplied or divided, we did it to both sides. Here we got 2 sides. We got 2 sides. So we got to do it to both sides. Whatever we do, we got to do it to everybody. And the first thing I want to do is I want to subtract 32. But why do I want to subtract 32? The reason I want to subtract 32 is because I'm trying to get that C by itself. Okay. So the first thing to do is to get rid of any other numbers that are possible. So I'm going to subtract 32 on everybody. That will get me where I want to go. Okay. So let's see. 5 minus 32, I guess, would be negative 27. And that's less than or equal to 9/5 C. And then 68 minus 32 would be 36. Okay. So as long as I didn't make an arithmetic mistake there, then the next thing, I still want to try to get C by itself. It has a fractional coefficient. And so how can I do that? Well, I think the way I'm going to do this is I'm going to multiply it by the reciprocal of that fraction. Okay? You can say, well, I divided both sides by that number, but I think it's easier to think about if I just multiply it by the reciprocal. So that's what I'm going to do. So to get this thing where I want it, I'm going to multiply everybody by the reciprocal of 9/5. So what would that be? That would be 5 minutes. Okay. Hopefully you can see, well, 9/9 cancels, 5/5 cancels. So that's pretty easy. So that's why I did that. All right. Now I just need to simplify where I can, and I think I can. Switch colors. So I have 27/9. That would just become a 3. 9 goes away. And then that's just -3 times 5, -15. So it's not too bad. 36 over 9, that simplifies. And I think that's just 4, right? So that would be 4 times 5, which is 20. So I think, barring arithmetic mistakes, this would be negative 15 C 20. That's what I think. Okay. So there it is. My work. Now, if I can, what I want to do is I want to answer the question how my MyLab understands it. And it says, what is the interval? Okay, so the way I have it, it's written with inequalities, but it wants it as an interval, as an interval notation. So on interval notation, we're either going to use parentheses or brackets. Okay. Let me switch colors for a small lesson review. Interval notation. You're either going to use parentheses or brackets or a combination of those. Okay. Some combination of those. Parentheses means everything but that number. Okay. But here we have the equal sign. So we want to include negative 15. We want to include 20. So I happen to want to include both of those. They equal negative 15. They equal 20. And all of the numbers in between. So in this case, in this example, I do want to just use brackets. So I'm going to use brackets because of the equal sign. So that's what I'm going to do. And that's why I did what I did here. You'll see that I have bracket, negative 15, comma, 20, bracket. That's including 15, that's including 20, and that's including the infinite amount of numbers in between those numbers. So there we are. And then the last part asks as a multiple choice question for us to select what it would look like on the real number line there. And you can see I picked A, so you can see what it would look like on the real number line, and it's 15 to 20, and we have those brackets representing that we want to include 15, negative 15, and include 20. And that's what we've done there, okay? So that's what I believe the answer is. That's why I believe that the answer is. And you've probably seen interval notation once before. But hopefully it'll come back a little bit. Again, we use the parentheses when we don't want to include the number. So if it was all of the numbers in between negative 15 and 20, but not including those numbers, we would use parentheses. Or there could be some case where you want to include negative 15, but not 20, and then you have some combination of parentheses and brackets. But brackets is when you want to include the number. If you took pre-calc or something, you probably saw a lot of problems where you solve for the domain of a function. A lot of trouble with okay, do I use parentheses for this part, or that can be really tricky. Luckily, this is fairly straightforward. All right, well, unless there's any questions, moving right along. I want to show problems 7 and 8, if I may. Let's take a look. Okay, still kind of in the algebra here. This is kind of a definition of a linear equation here. It can be written with capital A or it can be written lowercase a. But that's the general equation of a line. The y-intercept form is y equals mx plus b form. But here it says solve for y. So I'm trying to solve for y. So what we'll get out of this is the y-intercept form, the y equals mx plus b. All right, so here I am trying to do that. Ax plus by equals c. I want to solve for y somehow. So how am I going to do that? Well, just like we've been talking about today, if you have any of the other numbers, get them to the other side. Okay, if you have any other numbers, get them to the other side. So we want this AX over here. We just want it over there. And if it goes over there, it's going to flip sign. So we have C minus AX, or we subtracted both sides by AX. Now we have a coefficient on the Y, and we don't want that. We just want Y. They're being multiplied. So we want to divide by that B. So let's do that. Divide by B, divide by B. And that's going to give me Y equals C over B minus A over B X. And that is a version of the answer. And we can also write that with the X kind of to near the equal sign. So if we want, we could rewrite this as Y equals negative A over B X plus C over B. Believe it or not, that is Y equals mx plus b, where C over B is the y-intercept, and negative A over B is the slope, which we'll talk about more in a minute. That's how I would do it. That's connecting the general form of a line to the y-intercept. So now we have a way to get back and forth if we want. And, you know, that might be the first equation that we've derived. I think that would be the first one that we've derived from scratch here. So I don't know, maybe put a, I put a bracket here. So you might put a bracket. If you're taking notes, you might put one on there. So that's the first general equation we've come up with. All right. So I want to do 8. And not just because it's a jazz concert, but just because of what's going on in the question. A jazz concert brought in $207,000 and the sale of 8,200 tickets. If the tickets sold for $20 and $30 each, how many of each type ticket was sold? So what have we been talking about so far? We've been talking about lines, some inequalities, but I don't ever remember talking about jazz tickets up until this point. So it might feel like it's coming out of nowhere, but we can tie in what we've learned into this question, but it might feel out of the blue, I don't know. I kind of think of it, when I read this, I think of it as almost two things are going on at the same time. We have tickets that are like a $20 version or a $30 version. And I know some places do that, especially here in Bloomington. You know, they'll have student discount. So it'd be like student price and then general price, or the summer concerts, you know, depending on where you're sitting. Certainly the price goes up, 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 right? But here we have $20 and $30 tickets. And we know how many tickets were sold. And then we also know how much money was brought in. So we've only really learned about lines. How can we set this up where we can solve? So I think the way I'm going to think about it is I'm going to break it up into two different lines. I'm going to think of it as how many tickets and then how much money. So I'm going to have a tickets equation and a money equation. Okay. Let's do the money equation first. So there's a type of ticket that's $20. There's another type that's $30. And we know the total amount of money. So I'm going to set up a money equation. Here's my money equation. So one type is $20. Let's just call it A. Another type is $30. Let's just call it B. And we know how much money was brought in because they told us. So there's my money equation. So we have two variables, A and B. Okay. We could also call this X and Y if you wanted. no problem. A or B, X and Y, it doesn't matter. There's two different variables. So there's my money equation, and that's a line. Now let's think about what's going on with how many tickets. So there's the $20 ticket, there's a $30 ticket, and we know the amount of tickets sold is because they told us it's 8,200 in this problem. So the ticket equation would be the amount of A tickets plus the amount of B tickets equals the total amount of tickets. So that's two different lines there. There's the price and the revenue, and then there's the amount of tickets. All right, well, how does that help you? So I think if we found where these lines meet, where they intersect, we would find how many of each ticket was sold. So we have two different lines. If these cross each other at some point, then that's how many tickets were sold. So we could think about it as XY. We could think about it as AB. It doesn't matter. But these are two lines, and I think where they cross must be the solution to this system. So now we have to think, okay, well, how are we going to solve for this? And there's a lot of different ways, and we're going to look at a lot of different ways to solve this today. For this question, I think the easiest way to do it is called substitution. So I'm going to use the method of substitution, and I'll show you what I mean. So the way to sub is to solve according to one of the variables and then plug it into the other equation. So that's what I'm going to do. So I'm going to solve for B on that ticket equation, okay? And if I do that, that's going to be B equals 8,200 minus A. I wrote A, it's a little funny, but there it is, okay? So that's what B equals. Now, why did I do that? Solve for B in that equation. I'm going to use the method of substitution. So I'm going to plug this B here, right there. I'm going to plug it in there, okay? And then I can solve for A. And then once I have A, I can solve for B. And I'll be done. Okay, so that's what I'm going to do. So 20A plus 30 times B, I just found out that you could write B as 8,200 minus A equals $207,000. Okay. Now I have one equation with one variable, which means I can solve for it. Well, that's nice. So now I can solve for that. And when I do that, I can plug it in to the other equation and solve for the other variable. And that must be where the lines cross. Okay. All right, so let's do just that. So we have 20A plus, I need to distribute, distribution law of real numbers. Okay. So check my calculator. Well, 3 times 8 is 24. 3 times 2 is 6. Check my arithmetic. Is that right? I think it's right. And then distribute the A. I will tell you, one of my faults is I do make arithmetic mistakes, even though I'm a math professor. So you're welcome to check my arithmetic, and you are welcome to speak up and go, actually, it's this. So please keep me on my toes. I appreciate it. We all will make mistakes. All right, so I distributed the 30, and now it's negative 30A. And then that 207 is still there. Okay. Sometimes I drop zeros. That's another thing I goof up on. I make mistakes, you know. I do. All right, now let's try to get everything kind of condensed, put everything in its like terms together, and then we'll see where we are. Okay, so I have a 20A. I can use the spotlight tool. I have a 20, maybe. I thought I could. Maybe not. -20A, -38. So I'll put those together. And if I do that, what do I get? I get -10A for these numbers. -10, all right, plus 246,000, 207,000. All right, almost there. Trying to solve for A is what I'm doing. So I want to subtract 246 from both sides. Seven, 246. Okay, I think that's 39. And so if I divide by -10, that's just going to lop off a 0 and make it positive. So I think A equals 39. We see that was the correct answer. Now that we have A, we can find B. Or if you used XY, now you would solve for Y. Okay, well, how do you do that? So I'll switch colors because it's getting messy, but let's go back to A plus B equals 8,200. Okay, so A equals 3,900. If we subtract both sides by 39, I think B equals 43. Okay. That's using substitution. So what is substitution? Substitution is solving for one variable, then plugging it into the other equation and solving for the other. Now, you could do it with more than 2 variables, but we never did. We never use substitution for more than 2 variables because we're going to develop another technique if we have more variables. So if we have 3 or 4, we'll just have a different technique. But you can. It just gets really messy. And if you think that's messy, you should see what 4 variable is. All right. A lot of what happened here that causes the messiness, well, one's my handwriting, but the other is the numbers. Okay, the numbers are kind of big, have a lot of zeros. And that can make it look a little bit more intimidating at first, but remember, you can use calculators, so that can make it easy. And this is a common question. This is a kind of a classic algebra question. I mean, it doesn't have to be jazz tickets. In our case, it was, but it is a classic algebra question it's a ticket question. Okay, so once you see them, you'll see them a lot. So this would be one that I would recall. Okay, this is not just in your homework, but it's a good example. So the jazz ticket one, and you'll have different numbers in your homework that you would try. That's how I would do it. I would use substitution. Any questions about jazz tickets or concerts, or substitution, or anything like that? Well, we got some time for some more questions, and then we'll take a break, but I get a good amount of 1A at least introduced. I think the next one I wanted to bring up was, let's take a look at 11 and see if there's anything interesting about this one. Trout, I guess it's interesting, especially if you're a bear, but to determine the number of trout in a lake, conservationist catches 310 and tags them and releases them. Later, 177 trout are caught, and it's found that 31 of them are tagged. Assuming that the proportion of tagged trout in the second sample was the same as the proportion tagged trout of the total population, estimate the number of trout in the lake. So something I noticed when reading this was that the question is telling me the math technique to use in the question. It's saying use proportions. Okay. Now, I don't know the last time you took math classes, but if you were, I think everyone has to take geometry at some point, right? We don't have to write a proof or anything, but you probably did. So like this triangle is similar to this, so we can set up this proportion. That's going to be the same with this and our trout, believe it or not. But think of A over B is like C over D. You can set up a proportion. In the question, it tells you to set up a proportion. Well, what is our proportion? They're saying that 177 trout are caught and 31 of them are tagged. If before 310 were tagged, how many is total in the lake? So we're going to set up a proportion. So if these were proportional numbers, how much is in the lake? So set up a proportion. All right. So 31 of them are tagged out of 177. Okay. And before, there was 310. So how many is in the lake? This is, I mean, that's a guess. If it was proportional, how much is in that lake? So this is my proportion. So if it's 31 over 177, then the 310 would be over the total. So I think X is the total here. I mean, it's still a guess, but we can take an educated guess. We think that's the total. Okay. So how do you solve for that? Well, you can cross multiply. So you would multiply both sides and you get 31x equals 310 times 177. And then you divide both sides by 31. And you get x 310 times 177 over 51. And I think that equals 1,770 fishies. Proportion. Fundamental in mathematics, the idea that you can do. But you know, if you take a geometry, which I think everyone has to at some point, either your sophomore or junior year in high school, you did that all the time with triangles, but now we're other classes I teach, we do proportions all the time, especially in the lower level, lower than this class. We do a lot of proportions, like basic, everyday citizen math. You know, if these prices were proportional, if this population is proportional, do it all over. Here we're just kind of recalling it. Any questions about that? Let me make sure the picture. Hey. I think we've got time for one more at least. Let's see what 13 brings us. Oh, it's an easy one. Might have time for another one too. Okay. Find the slope and the y-intercept of the graph of the equation. Y equals x over 4 plus 4 over 9. Well, if you recall, y equals mx plus b, where m is slope and b is the y-intercept, then you already know the answer. Now, M stands for slope. Why on earth would we use the letter M to stand for slope? Because the French guy is the one that developed all of this, and it's the French word for to climb. So it's kind of like mountainous. The person that developed this thought of it as the climb of the line. Climb of the line. So that's where the M, it's like the French word for, it's kind of like mountainous. I don't speak French, but that's the idea. So it's how steep it is. How steep is it climbing? And B is the base. So B is the base of the climb. So there's your base. That's where that's coming. That's the y-intercept. So if you just understand that equation, then we have it. Well, then the slope, the rate of change, the climb, is 1/4, and the y-intercept is right there. It starts at 4/9. That's the base. That's where it's starting. It's easy enough. You just have to recall those concepts. Just a similar idea, but a bit trickier. So we want to find the slope of a line that passes through the given points, find the standard form of the equation of the line, and find the slope intercept form of the equation of the line. Well, I'll just tell you right now that equation, we can find y equals mx plus b, or you can find y. So I'll just give those equations first. Slope of a line. Do we remember how to do that? Well, the equation for a slope was y2 minus y1 over x2 minus x1. It's the rise over the run. Rise over run. Rise over run. It's how it climbs. Rate of change. How the line is climbing. And so it doesn't matter what point you consider the first one or the second one. It doesn't matter. You'll get the same answer. But we need to plug this in and see what happens. So that's what I'm going to do. So I'm going to find the slope. So in this question, the slope would be, I take the difference of the y's, 9 minus 9, over the difference of the x's, 3 minus negative 2. What do you get? You get 0. You get 0. Why do you get 0? Well, you get 0 because 9 minus 9 is 0. Now, the reason why we got 0 is because the y's are the same. And if this is a straight line, that means the y's are always the same. It means the y's are always the same. So if I graphed it, it's going to look something like just a horizontal line, where y is always 9. That's what happens when you have slope of 0. It's just a horizontal line. So what is the equation for this line? It's just y equals 9. Y always equals 9. There is no slope. It doesn't climb. It just starts at 9 and it stays there. And that always happens if you have slope of 0. There's no change. So it's just always the same y number. So no matter what x you put in there, you always get 9. So there you go. So I'll go down just a little bit so you can see what that last part is. But it says, what is the equation of a line slope-intercept form? Select the correct choice below, and if necessary, fill in the answer box to complete your choice. So this is just y equals 9. It's a horizontal line, and it always equals 9. But that would work for any number. Any number. And the x-axis is if y equals 0. If that's the x-axis, is y equals 0. That's a horizontal line. So if you're dealing with a horizontal line, it's just y equals that constant. That's the idea. So that's kind of interesting. See, we're at 208. We have time. Probably should have taken a break. Can I just explain this one and then we'll take a break? So the temperature at which the water starts to boil is called the boiling point and is linearly related to the altitude. Water boils at 212 degrees Fahrenheit at sea level, 193 degrees or 193.6 degrees Fahrenheit at altitude 10,000 feet. Find the relationship T equals mx plus b, where degrees, T is degrees Fahrenheit, X is altitude. Find the boiling point at 2600, find the altitude at this temperature, and then graph it. Okay, so can I at least get you started on this one? I think it's worth at least mentioning, because it doesn't explicitly mention it. I think it's worth at least seeing at sea level, this has this temperature. At 10,000 feet, it has this temperature. So depending on how they're considering X and Y, we need to figure out what our 2 points are. Okay, so I see from this equation, T equals mx plus b. Okay, temperature is the Y. All right. So what is that first point? The first point is at sea level. What on earth does that mean? I think that means at altitude 0. That's how I take it. I think that means altitude 0, it boils at 212. At 10,000 feet, it boils at 193.6. There's 2 points. From there, you can find your line. So now you can find your line from m equals y2 minus y1, x2 minus x1. You have 2 points. You can find your slope. From there, you can find your y-intercept. In fact, we know what the y-intercept is because they gave it to us. So you'd be on your way. So that's at least an introduction. But I think that sea level could cause confusion if you are a little bit rusty or if you have a little bit of math anxiety, I think, because it doesn't say it. So I thought maybe I'd mention it. All right, so that'll get you started on it. All right. Okay, so I'll take a 10-minute break. We'll come back and we'll talk about part B. Right? Okay, so I'll take a break, 10 minutes. I'm right back. I meant to do it earlier, but I got to talk. Stay. Back from break. We're thinking about 1B. So we're thinking about the second half. So what we're going to lean into is some equations, and we're going to start talking about matrices. The way we're going to introduce matrices is really just a method of solving system of linear equations, and then later we'll go further and further and further with it. So hopefully you can see the screen. I need to pull up the chat in case there's any questions. So match the system of equations below with the graph and use the graph to solve the system. So we have two lines and two variables, x and y. Okay, so it says use the graph, so there must be some graph below. Where's that located? Here we go. Okay, now you're going to see a lot of this in the homework, and it's pretty ugly looking. And what I found is I have to press this button here. Let's see if I can show you. So I've been pressing this button here to be able to look at it. And generally with practice, I can get an idea of what I'm looking for, but I always have to seem to click that button to look at it. So look, and it pulls this up for me. Okay, so I can get a better look at it, and that helps. And then on your computer, you can kind of zoom in if you need to. That's the idea. So we have 4 of those, and we need to somehow match the system of equations below with its graph and use the graph to solve the system. There's so many different ways we could go about this. I think the way I'm going to show you today is, let's just look at what our coefficients are here. For the x's, we have -6 and 3. And so you can multiply an equation as long as you do it both sides. That's what we've been saying. You can multiply an equation on both sides as long as you are consistent. So that's what I'm going to do. -6x plus 2y equals 12. Now, what if I multiply the second equation, that 3x minus y? What if I multiply that by 2? If I do that, I get 6x minus 2y equals 0. Why would I do that? Because now my x's are equal and opposite. Right? And something happens if you add them up. If you add these up, you get 0 plus 0 equals 12. Okay? So I just solved and proved that the number 0 equals 12. What on earth does that mean? What on earth does that mean? 0 equals 12? Well, that can't be right. So these lines do not intersect. That's what I've showed. So by doing that, I've showed that these lines don't intersect. So that means they're either the same line or they're parallel lines. That must be the case. And so I've ruled out this option altogether. It can't be that, because those are intersecting lines. So it can't be that. It has to be parallel, or it has to be just a single line. Well, I don't think this is a single line, because even when I did that, they weren't the same. So these aren't the same line. These must be parallel lines. Okay, so now I'm down to 2 choices. So which one is it? Well, we can also look at the intercepts. See what tool does here. So we can look at the intercepts of those 2 and think about how this is going to work. So I think it's got to be this one or this one. It's got to be the parallel. So which one is it? Why is it? Okay, let's think of the x and y intercepts. X and y intercepts. So if x was 0, then y equals 0. Okay. If y equals 0, then x equals 0. So that second equation goes through 0, 0. Has to. Right? Well, is it positive? Is it negative? Let's look at the first equation. If x equals 0, then y equals 6. Okay. If y equals 0, then x equals -2. Okay. So let's take a look. Is that going on here? Well, that's pretty ugly where I have it there. Is there a way to look? So those are parallel lines. It does go through 0, 0. That's what I need it to. It has the wrong y-intercept. Has the wrong y-intercept. It is parallel. That's what I need. It isn't the same line. That's what I need. It goes through 0, 0. That's what I need. But it has the wrong y-intercept. So it's close, but it's not perfect. So I don't think it's this one. So now I'm down to this one. There. Now it does have the right y-intercept. It does go through 0, 0. They are parallel lines. So there we have it. Has the right x and y intercepts. Parallel. Not the same line. Must be the case. Okay. Now, of course, the other way would just be to graph it from scratch. You could just graph those by yourself, but I know you're looking at the homework. It's asking you to do it through multiple choice, so I might as well teach through multiple choice. But that's the idea. In a more general way, you would have to graph it yourself, or you would use a graphing calculator to do it. But here it just said pick the right one. So that's where I'm coming up with those. That's the idea. And if these if they intersected somewhere, that would be the solution. But these are parallel, so there is no solution. No solution. And we'll see that in other examples too. So what is the solution to the system? Not just one of them, but to the system. That's where those lines intersect. If you remember, what question was it? The tickets, the jazz tickets. We had two lines and we found where they intersect. Here they don't. So there's no solution to the system. No solution to the system. Right? Sometimes you'll see me write, oh, not that way. Sometimes you'll see me write it like this. The 0 crossed out, that just means no solution. There's no solution. These are parallel lines. Okay. I think there's no solution. There's no point in which those two lines cross. I showed a couple different techniques to show that. We saw the graph. That's the idea. Of course, you can graph them yourself, or you could even use a graphing calculator to graph them for you. And we might look at that later too. Keep going. Solve the system of equations by graphing. I think this one I had to graph myself. Okay. Yeah, really, if I have to graph something by myself, let's say I was just given this on a piece of paper, on an exam piece of paper, how would I graph it? I would find the x and y intercepts. That's how I do it. Okay. So that's how I do it. I just find the x and y intercepts. And often, the way I like to do it is I like to think, okay, well, let's just solve the x and y intercepts for this line. Okay. If x equals 0, then you have negative y equals 6. That means y equals negative 6. This is for the first equation. If y equals 0, then you have 2x equals 6. X must equal 3. So there are my x and y intercepts. You have 0, negative 6, and you have 3, 0. So that's one of the lines. I'm going to do the same thing for the other line. So for equation 2, if x equals 0, then 2y equals 8, y equals 4. If y equals 0, then x equals 8. So my x-intercept must be 8, 0. Now I had to use the MyLab tools to be able to plug that in, but that's exactly how I did it. I set up a line, I clicked On my y-intercept, x-intercept, it made the line. Y-intercept, x-intercept made the line. That's how I do it. On a piece of paper, I would just draw it the best I could. That's the idea. That's the idea. Now, their intersect, where those lines cross, that's the solution to the system. Right? Is that clear enough visually where we can see? Trying to tell, but that's the best. Might be a little hard to tell, but from the graph, I think it's 4, 2. That's where the lines are crossing. But of course, I could just use algebra. We could use substitution to solve for that, or we could use elimination method to solve for it. Either way. That's the idea. Let's see. Look at 3. Solve by the substitution method. Well, the computer's not going to know if you use the elimination method or if you use a graphing calculator. You know, the computer doesn't know, but I'll at least show you the way it says to do it. So that's what I'm going to do. All right. Substitution method. How do we do that? We solved for one variable and then we plugged it in the other equation, solved, and plugged it back in there. So sub. So how do I do that? Well, we got to pick where we're going to go. I think for this, I'm going to have y equals 4. No, I got to be careful because that's a negative y. 4 minus x. And y equals x minus 4. Pretty sure I got that. Okay, I think I got that right. So I moved the x on the other side. That's negative y. So I'd have 4 minus x, but then I multiply both sides by -1. So I think I get y equals x minus 4. All right, now I can take this and plug that into here, hopefully. So that's what I'm going to do. Okay, switch to black. So 5x plus 2 times x minus 4 equals -43. Okay, so now we need to distribute. (5x plus 2x minus 8 equals -43. Pretty sure that's right. (7x minus 8 equals -47. That's a 4, not a 9. Sometimes 4s look like 9s. Is there a problem? Oh. Thank you. And then, is there a problem with the Pearson? Somebody said that they can't log in. You have to go through the Ivy Plus bookshelf to get there. So go to our course website and then just hit Ivy Plus bookshelf. That'll get you there. Okay. Okay, what happens if we add 8 to both sides? What would we get? What would we get? I feel like
You need to change the last numbers on the bottom equation to negative 40.
yeah, that doesn't make sense. I think I got distracted. I was worried about the Ivy Plus. Adam says, I do that and then it asks me to sign in. Owen says, yeah, you got to make an account.
I think you just make an account with your Ivy Tech login and then it
Yeah,
works.
definitely. Yeah, it's part of the course. Where are we in this? Is that still 43? And then that would be 35. That would be negative. So if x equals -5, what does y equal? We can go back up. Let's go back up. So we had x minus y equals 4. We think x equals -5. Y must equal -9. And that's using substitution method. Adam, were you able to log in? Maybe hang out after class if you're still having trouble. We can look at it. Okay, did that make any sense? Just trying to think of what might be wrong with Pearson while I was doing it, so I was a little distracted, but hopefully it's working. Sounds like it's working for the other folks, so that's good. All right, solve by using substitution or elimination by addition. We get the choice. We just did a substitution, so maybe I'll show elimination just to mix it up, but you can, with substitution, you can do the same thing. Let's see what elimination does. So we need to think, is there something I could multiply the first equation to eliminate one of those variables? That's the idea. So for instance, is there anything I can multiply 7 by to get positive 56? Like, is 56 a multiple of 7? Can anyone think of it? Is there anything I can multiply 7 by to get 56?
8.
8. So if I do that, let's multiply this by the first equation by 8. Then I get 56x. 9 times 8, 72. And then 8 times 8, 64. Okie dokie. Now, I didn't do anything to the other equation. Okay. Now, the x's are equal and opposite. Hey, Adam got it. I'm glad.
Isn't that a -72?
Yes. Thank you. Okay, what happens if I add these equations together? 56 minus 56 is 0. 72 minus 72, whoever helped me there, thank you. That's 0. And then I'd get 1. So I get 0 equals 1. So I just proved that 0 equals 1? No, I didn't prove that. So that means there's no solution. These lines do not intersect. So that's cool. But these lines must be parallel. They must be parallel. So that's going to happen. Sometimes you'll get something like 0 equals 0. If you get that, if you get 0 equals 0, then that means they're the same line. There's infinite solutions. In this one, we got something like 0 equals 1. If you get 0 equals 1, that means it doesn't work. It doesn't work. That's the idea. So I don't think there's a solution to this. So if we graphed it, we would see these must be parallel lines. So there's no solution. Let's see what question 7 brings us. Solve this system of equation using substitution or elimination method by addition. I don't think there would be any advantage to one way or the other. I think generally they would be the same. If you use elimination method, if I use elimination method, I would probably get rid of the decimals by multiplying by 100. That's usually what I do. If I use substitution, I wouldn't worry about it. I would just use my calculator to help me out. I wouldn't have to worry about it. Is there one way over the other you would like me to do it? I'll let you guys choose. Do you want to see substitution or elimination for something like this? I think either way works. Either way would work. Either way you want to see it. You want to see another substitution or elimination? Elimination method. I have elimination. Okay. So if I use elimination, I would prefer to not use decimals. So it's my question. That's how I'm going to do it. So I'm going to move that decimal point so I don't have to do it anymore. So I'm going to multiply. Well, I have to think, what am I going to multiply? I have to make everything the same. So what I could do is I can move the decimal place 2 spots, and then I wouldn't have any decimals at all. And that might help me. So if I multiply 0.5 by 100, no more decimals. I'm kind of looking at this one here. So I want to move that so I don't have 0.18 or 1.8. I'd rather just deal with -18. So I think I'm going to multiply everybody by 100. And I think that will be easier for me to think about. So that would be -50x minus 60y equals -18. No more decimals. If I want, I could multiply the top one by 10, and I wouldn't have decimals either. You see that? So if I move this over 1, no more decimals. So that would be 10x plus 10y equals 4. No more decimals. Much easier for me to think about. Now, I can either eliminate y first or x first. I have to make a choice and just go with it. Usually students prefer if I solve for x first. So is there a way we could eliminate y? That is to say, is there something I could multiply? Let's use vanishing pen. Is there something I can multiply this number here to make it positive 60? What could I multiply 10 by to get 60? 10 times what equals 60? 10 times 6. would give me 60, and then they would be equal and opposite. So that would work. So I'm going to multiply the top equation by 6, and that will do it for me. So that would give me 60x plus 60y, and 6 times 4 is 24. And let's just rewrite that. Negative 50x plus, minus. Now we can just add them together. We have the y's are equal and opposite. Let's add these together and see what happens. So 60 minus 50 is 10. So that's 10x. That's 0. And then 24 minus 18. And that's 6. So we have 10x equals 6, which implies x 0.6. 0.6. Now we know what x is. We can solve for y. I'm going to look at what was the simplest equation I could plug that in. I think the first one is the simpler one. So this one is much simpler for me to think about. So that's the one I'm going to use. And so x plus y equals 0.4 becomes 0.6 plus y equals 0.4. And so y equals 0.4 minus 0.6, or like 40 cents minus 60 cents, negative 20 cents. Any questions about this? There's a lot of steps I have to do. And there's also, different problems call for different things. And that just comes from practice of, oh, well, because it's this, I'm going to try this. I'm not solving it very algorithmically. I'm just kind of doing the question in front of me. But I don't really like to use decimals if I don't have to. If I'm using a calculator, I don't really care. But if I was going to use the substitution method, I probably just would have left it as decimals and then just plugged in my calculator and had it do it. Okay. All right, any questions about that one? That was number 7. Let's see what number, I know there's some word problems in here. Let's see what number 11 brings us. Oh, here we go. Here we go. We got a word problem. Let's check and see. Sorry for the flipping. Just double check. I'm not going to solve this one for you, but I'm at least talk about it, okay? If you have something like this, y equals, and you want to solve that system, you can set these equal to each other. It's really easy once you understand that. So if you just set y equal to y, then in these numbers, you just have negative x plus 8 equals 4x plus 5, and you can solve. It's that easy. Or you can use a graphing calculator to do it. That's another way. However you like it. The weird thing about this one, I think this is the one that I plugged in as a fraction. I plugged in my answer as a fraction and it counted it wrong. And so I'm like looking at my answers, maybe I made a mistake. I don't know. Kept looking, I couldn't find the mistake. Then I looked at the directions again, and it said round to 3 decimal places. It feels kind of unfair to count it wrong, even if I got it right as a fraction. Actually, the fraction more right. So watch that. That's something you have to practice just in the digital world in college. If something's going wrong, look at those instructions one more time and see, did it want it as a reduced fraction or did it want it as a decimal? And that's something I came across when playing this question. So word to the wise, even if we had to put in the right fraction, it would count it wrong. So that's annoying. Okay. Let's find those word problems. Okay, company markets exercise DVDs that sell for $29.95, including shipping and handling. The monthly fixed costs, advertising, rent, etc., are at $37,350, and the variable costs, material, shipping, etc., are $7.45 per DVD. Find the cost equation and the revenue equation. How many DVDs must be sold each month for the company to break even? And graph the equation and revenue equations in the same coordinate system to show the break-even point. Interpret the regions between the lines to the left and to the right of the break-even point. Well, that just flows right off the tongue, okay? And it probably feels like this is nothing like what we're talking about, but this is an application of what we're talking about, okay? So this is where we're, you can't complain. You can't criticize. We never went over real life material. Here it is. Okay, businesses, costs. We might not need DVDs anymore, but there's always costs with manufacturing. So here we go. Now I claim that all of it's just the lines. It's just straight lines. Y equals X plus B. We just set them up. Okay. So what's going on? We're selling the DVD for $29.95. Okay, so that's going to have to do with revenue because that's the money coming in. All right, fine. The monthly cost, rent, is $37,350. So this must be a pretty big place, I'm guessing. And then it cost us, with the case and everything, $7.45 to make the DVD. Okay, or maybe we're making some like a video game or something like that. You still have to have your case or whatever in the store. So there's some cost in producing that, and then there's cost for the manufacturing. So we have many costs at the same time, and that's very realistic. So what's the first thing we want to do? We want to set up the cost equation. All right. Now the cost equation is, this is non-variable. That's a static fixed cost. That's like the rent and electricity and water and everyone's payroll, everything. So $37,350 per month. Okay. So that's a fixed cost. And then we have $7.45 per DVD manufactured. So the cost you see right here. The variable, the slope is $7.45. Okay. So slope for cost is $7.45 per DVD, and that's what we're setting up. The y-intercept, the B y-intercept, or we call it B, equals 37,350. Okay. Now this is very similar to my calculus course that I teach, but they have to do a couple other sets that you don't have to do. But this is very similar to a calculus question. What's the revenue? What's money coming in? Money coming in is we're selling this at $29.95. Okay. So each DVD that's sold, or video game or whatever, each one that's sold, we got $29.95 coming in. So the slope for the revenue is $29.95. Okay, that's our slope. For revenue, money coming in. How many do we have to sell to break even? Really, we're saying, how many do we have to sell to pay for the rent of this warehouse and all the industrial machines in there and the people that work there? So we want to set these y's equal to each other. Okay, we have cost equals $7.45 plus 37350, and we have revenue equals 29.95x I claim if we set these equal to each other, we see where we absolutely break even. That's where we break even. So let's do that. It's y equals y, 29.95, x equals 7.45, x plus 37.350. And we want to solve for x. Solve for x. So we subtract both sides by 7.45. I got 22.5x, 37.350. Divide both sides by $22.50. 37350 divided by 22.50. I'm getting x equals 1660. Okay. I got that. I mean, the question reads to me, we're all starting from different spots. I don't know. When I first look at this question, it looks like it's going to be nearly impossible. Like it reads really intimidating to me, but it's just straight lines. It really is just straight lines. We have this cost equation, that's y equals mx plus b. We have this revenue equation, that's just y equals x, y equals mx. There's no slope, or I'm sorry, there's no y-intercept. We set them equal to each other, and then we can solve for the break-even point. Okay. Is there any part of this that you would like me to go over again? I did go over a lot, and this is being recorded, but is there anything you'd like to see again, or how I got that, or?
Once you get 29.95 as the slope.
As the slope. So that came from the 29.95 came from it sells for 29.95. So people don't buy DVDs as much anymore, but if we think of like a Nintendo game, okay, it's over at Target, the Nintendo game, let's say this game is selling for 29.95. That's the money coming in. That's the money coming in per game sold. Money going out is it took $7.45 to make it, and there's just this static manufacturing cost of $37,000 per month. So that's where the 29.95 came from. And then what I did was I set those two equations equal to each other, and that's just the break-even point. So that means that if they're not selling 1,660 of these DVDs per month, they're at a loss. So that's not good. They really got to sell them. Hopefully that works out for them. Let's keep looking at this. I think there's a graph portion to this. Yeah, there is. All right. I think I took a picture. I'm going to take another one just in case. Clear so we can look at the. So we have two lines, right? Y equals 29.95x. And then y equals 7.45x plus 37,350. So that's two lines. One of them goes through 0, 0, and one of them doesn't. And I don't know why, but for some reason I think of revenue as red. And I think of cost as blue, but I don't know why. 7.45x 7. So we're looking at these two equations. Okay, where they intersect is where we break even. And we want to figure out what this is. Well, I know this is a y equals x. This is a y equals x type of equation. So I know it's going to go through 0, 0. And I know what my y-intercept is. Both of these are positive. So I know that's going on. From there, how can you choose? Well, we We figured out where the break-even point is, so we know where that is. And yeah, so that's a pretty good clue of what's going on. Now I chose, it was this one. Let's see if I can justify it. So it says on the X, I will say you got to really watch where your how the units are working. But this is 3,400 at 10, 100,000 there. So I think this has to be it. We see the red is the Y equals X. That's our revenue. We see the blue there, 7.45, increasing each time, starting at 37,350. So there we are. We know where our break-even point is roughly on this. X equals 1660. So that helps. And then there might be a portion where it asks us to interpret what this means. Let's see if I can pull that up for you. I think there was a part where it asks you to interpret. What region between the lines to the left? What does the region between the lines to the left of the break-even point represent? Try to explain that. So it's talking about this part. What does this represent? What does this part mean? What does that mean? So that portion is manufacturing at a loss. So here we're at a loss. Okay, we're making them, we're still making money, but we're losing. So this is at a loss. Okay. What does this portion represent? That's the next question. What does this represent? That's profit. That represents profit. Okay. So this is my loss. This is my profit. That's the idea. So, it's just, that's just how the numbers work out. Now you can imagine in real life, there's way more than two variables, right? There's going to be way more than two variables in real life, in real manufacturing, shipping, everything. People, in real life, more variables. But this, you got to at least start with two to understand it. And this isn't a business class, but this is enough to get you going of understanding that. So if you're going into that world, this is enough at least to get going, because you got to start with two to get going. One's too little. Two's just enough. Let's take a look at 13. Write the system of linear equations that represents the given augmented matrix. Actually, let me go back and just make sure. Sorry. I think I need to go back. Yeah, I'm sorry. Let's do number 12. I don't want to skip that one. Number 12. Animals in an experiment are kept under a strict diet. Each animal should receive 22 grams of protein and 3 grams of fat. The laboratory technician is able to purchase 2 food mixes. Mix A has 30% protein and 5% fat. Mix B has 40% protein and 4% fat. How many grams of each mix should be used to obtain the right diet for one animal? Okay, before I'm manufacturing DVDs, now I'm feeding animals. This is crazy. Okay, but I claim it's all lines. It's all straight lines. You just need to see where those lines intersect. They're just applications. So now you can think we're helping animals at the zoo or the vet. But this can also really help if you're considering recipes, if you're considering scheduling, it all ties up. This all ties up. It doesn't, we're just writing stories that connect them. But that's the idea. Okay, so I claim these are just lines. Well, where are these lines? So if you remember before, we had, you remember our ticket question? Our jazz ticket question? It's similar to that. It's similar to that jazz ticket question we talked about before. I told you that was kind of an important one. That's one to review for sure. I claim that this is similar to that. Let's see how that would work. So the animal should get 22 grams of protein and 3 grams of fat. So I think I could come up with a protein equation and a fat equation, just like I did with price and tickets. That's what I think I can do. I'm going to try to do it. So I'm going to come up with a protein equation, and I'm going to come up with a fat equation. Okay. Now my variables are A and B because I'm trying to solve for mix A and mix B. So that's the next thing to do. All right. Well, mix A has 30% protein. 30% for A. Mix B has 40% protein. And the animal needs 22 grams. So there is my protein equation. My variables are mix A, mix B. Those are my two variables. All right, I'm going to try to come up with my fat equation. So with my fat equation, mix A has 5% fat. And mix B has 4% fat. And the animal needs 3 grams of fat. Okay, those are two lines. Two lines. So if we can figure out where those two lines intersect, that's how much we need of each one. That's the idea. So if we can figure out where these two lines intersect, then we can figure this out. All right. I'll remind you that 30% is really the number 0.3, 40% is the number 0.4, 5% is the number 0.05, and 4% is the number 0.04. That's something to keep in mind. Okay. So many choices. So many choices with algebra. What we can convert these to percents, or we could graph them, or we could use an elimination method, or we could use substitution method. So many different things we can do. But let me at least write what we have so far. So we have 0.3a, 0.4b equals 22, 0.05a plus 0.04b. Watch those zeros. That's something that my quantitative reasoning students always goof up. So watch those zeros, okay? Watch them. So that's what we have. That's what percent means. Percent, 100 cents in a dollar. So we can't forget those. If we want to use elimination method and we don't want to use decimals, we could move the decimal. We just have to move it for everybody. Okay? And that might make it a lot easier. So with that top equation, I have 0.3, 0.4, 22. So I can move the decimal once for everybody, and it would be the same ratio. Okay. So I can do that. I can multiply everybody by 10. So that would be 3a, 4b, 220. And I personally like dealing with whole numbers if I can. But it's up to you. All right, the next one, I have to watch out because it looks like I gotta move it twice. So 1, 2, 1, 2, that means 1, 2. So that's gonna become 300. All right. So that's 5A, 4B, 300. All right, at least everything is whole numbers. That's kind of nice. That's kind of nice. All right, let's use elimination method. What number could we eliminate? I see that the B's are equal and opposite, so those are kind of teed up, ready to go. Those are kind of ready to go. So if I'm thinking if I multiplied the second equation by -1, it would be the same. And we would be ready to go. So -5A minus 4B equals -300. So let's see if we can add these equations together. Now we'll eliminate one of the variables we can solve. So 3 minus 5 is -2. And 220 minus 300, I guess would be -80. Okay. And -80 divided by -2 would be +40. Go. Our first solution. To solve for B, we can use any of these equations as long as I didn't make any arithmetic mistakes, and that's a big caveat. But as long as I didn't make any arithmetic mistakes, I can plug A equals 40 in any of these and get my B, right? So I just want to pick the one that I like the best. Doesn't really matter. I kind of like whole numbers better if I can. Let's just pick this one. Why not? This has whole numbers, it's not too bad. Let's see. 3 times 40 plus 4B equals 220. Solve for B. 3 times 440 would be 120. 220 minus 120 is 100. And so B equals 5. It must be the case. Oh. Questions about that? Using the elimination method again. Question. So that's the idea. Still pretty common. I teach this in an algebra course. So this is still just intro. It's kind of a difficult intro algebra problem, but it's still just intro algebra. We haven't really entered in finite as far as this question goes, but let's see what happens on the next one. So question 13, write the system of linear equations that represent by the given augmented matrix, assume that the variables are x1 and x2. This also probably seems like we've never done anything like this. This is all brand new, but it's not. This isn't new. This is just the next level. This is your level. So it's on algebra. Now we're into finite. And now we're going to take those system of equations, just like we had with our recipes. We're going to take this and we're going to go to the next more advanced mathematics that we can use. And it's not just for no reason. The reason we're going to do this is because this technique will afford us to be able to go more and more variables, because in reality, you have more than two. So that's what it's going to afford us. So what is this thing that they're calling a matrix? What is that? Well, it's a list of numbers. What list of numbers? What is this? And then it also says, assume that your variables are x1, x2. What's that all about? This really is just the same thing we had in our previous questions. We had A or B, we had X or Y, same thing. So this is just two equations, two unknowns, but it's just, we only put the coefficients in the box. We don't care about X and Y. We know that's X and Y, right? So this matrix, that's what that box corresponds with all the numbers. That's a matrix. And this means you have 3x plus 2y equals 7. It's just an equation. Just like we've been dealing with before. It's just a line. It's just a line. And then the second equation is 1x, so just x, plus 6y equals 9. So that matrix is just, it's just lines we've been talking about. Just lines. Right? Just lines. Now, X and Y, A and B, that's all fine. And this one, it wants us to go even more general. Use X1, X2. So we're really going general. As general, just the idea that it's just two different variables. That's the idea. So you're just transferring that to be 3x1, just meaning the first variable out of 2. And then this is x2 equals 7. And x1 plus 6x2 equals 9. Okay, that's the idea. So it's just x and y, a and b. It's all the same. It's just lines. It's just lines. But that's the idea. So you can see where I put 3x1 plus 2x2 equals 7. You can see how that works, okay? Probably the trickiest thing about this problem is entering it in the computer. Probably the trickiest part. Maybe I can show you that. Because it is a little weird. How do you get that little 2? We go similar question. Right? It's the same old thing, but it's just different numbers. So I'm going to try to enter it in so we can see how that might. The first one is 437. Okay. So 4x, and there's a little button here. I don't know if you can see it. There's a little button there. It says subscript. So I do that, and I want that to be x1. So 4x1 plus 3x subscript 2 equals 7. Easy. All right, what about this one? That's 1x x subscript 1 plus 5x subscript 2 equals 8. That answer, and so I think the hardest thing about that question really is entering it in. Right? And it already went to the next question. So hopefully that gives you an idea. Those little buttons there, those can be very helpful. And then I'll also say, since, you know, it is a good portion of this is online, take note that you have more options in case you need the infinity symbol or anything like that. You have all those choices. And another thing is a lot of times they'll even give you the, if you just hold your mouse over it, they'll even give you what you could enter in the keyboard. If you want to learn all the keyboards, you can, you know, like if I want to enter in square root, I can press that button and do square root, or I can do /sqrt and then that will pop up. And then they have one for infinity fractions and all that. So I know you're going to have to interact with this program, but as far as the homework goes, it's probably the, I mean, it's not saying much, but it's probably the best one out there. So when we switched to, when Ivy Tech switched to free textbooks, the math department was like, well, let's go with Pearson because they have the best homework system. So even though it's not perfect, and you'll definitely feel that, unfortunately, it's probably the best one. You know, and reach out if you get stuck on something. It's not too bad. 13, 14, 15, 16. Let's look at 17 and see. Warning, warning, warning. I want to save the best score. Why wouldn't I? All right, let's look at 17. Solve using augmented matrices. So now I'm going to, two equations, two unknowns. You've seen me do substitution. You've seen me do elimination. Let's see me do matrix. It's the same thing. It's the same thing. I'm just using a new technique. But the thing with this using matrices is it's going to afford us much more when things get more complicated. Oh, there's a question. Does it automatically sync with Canvas? Because I just got notified that my grade on one of my sites didn't finish yet. So, so let's talk about it. So somebody got notified. They probably, you either just looked at your homework, and so that would just be a 0 because you haven't done it yet. But that's not a final 0. That's just an initial 0. So yeah, it is going to sync. It syncs periodically, like 3 or 4 times a day, or maybe more. But yeah, just because you look at a homework assignment, it doesn't mean that's your final score. Okay, and then homework will always be due the next week. But this homework is due a week from today. Okay. But that's a good question because I didn't mention it. Didn't think to mention it. But no problem. You got a week to do this homework and a week to do the quiz. Okay. And I guess since we're talking about homework and all that stuff, I don't really have office hours. I'm not a full-time professor. And really, in truth, office hours have kind of gone by the wayside because if we're not meeting in person, what would be the point of me sitting, waiting for someone to show up at a particular time? Almost no one ever does. So really, there's no office hours because it's always office hours. Every day is office hours. So you just email me. I'm really stuck on question 13. I don't get it. I'm trying this and it's not working. I'll shoot you back a reply. Okay. So there's no office hours because there's always office. There's no point in me going. I only answer questions on Friday from 1 to 2 when no one's going to show up and no one needs help then. You need help when you're working. And you guys probably like to work really late. Okay. And I don't. I like to work in the morning. So I'll just answer usually in the morning. Have we solved this problem yet? No. Solve using augmented matrices. So I want to turn this system of equations into matrix. All right, let's do that. Okay. So if we can go one way, we can go the other way. We just want to record the coefficients. So 3, 2, and 9. And we have 1, -1, -2. All right. And I'll say we'll be done when we can leave. We'll have 1, 0, 0, 1. And then this will be our answer for x1, and this will be our answer for x2. So that's what the matrix will look like when we're done. We have to work on it, but when we're done, we'll have that 1, 0, 0, 1. Okay. That means x equals this number, y equals this number. But we gotta do some work to get it there. Okay. All right, so let's do that work. Okay, there's so many ways to do it. The standard way is to make that first number a number 1. Okay, so the first time I learned this was you want to make this a number 1 in the end, so you want that to be a number 1. And there's lots of ways to do it. We could divide the first equation by 3. That's one way to get it. The other way is we could flip the order of the equations, and then we get it for not having to do anything. So that's what I'm going to do, because this problem, the way it's set up, I could just switch the order of equations. I get a 1 for free. So that's what I'm going to do. So I'm going to write this down, and that's a good habit to get in. My professors taught me this. I'm going to suggest it to you. I'm going to swap out row 1. Whoops, I don't want vanishing anymore. I want to swap out row 1 for row 2. Okay, I'm making a note to myself, row 1 for row 2. I get a 1 for free. I don't have to calculate anything, and that way I don't have to deal with 2/3 if I do it this way. Okay, so I get 1, -1, -2, 3, 2, 9. Okay, now it's number 1, exactly what I needed it to be, and I didn't have to introduce fractions. Great. Now I want to make that 3 into a 0. I want to make this into a 0 because in the end, that needs to be a 0. How can I do that? So the way I'm going to do that is I'm going to use this 1 as my pivot. So I'm going to take that 1 and I'm going to eliminate that 3. How do you do that? If I go -3 times row 1 and add it to row 2, which will become my new row 2, that will make that 3 into a 0. So what am I doing? I'm getting rid of that 3, getting rid of that x. I don't need it. I'm trying to solve for 1x. Okay? I'm using that 1 to eliminate it, but there will be consequences for doing this. We can deal with those when we get there. So I'm going to go -3 times row 1 plus row 2. That becomes my new row 2. I can multiply an equation by anything I want. I can add an equation as long as I do it to everything. So this is all within my rights to do. All right, so let's do it. If we do this, row 1 does not change. Row 1 did not change. Okay, but row 2 does change. So what happened? Well, by design, that goes to 0. That was my goal. That's how I set this up. But there's consequences. Okay, what are the consequences? Well, I have to go -3 times row 1 plus row 2. So it's -3 times -1. That's 3 plus that 2. Let me say that again. -3 times row 1. So it's -3 times -1. That's 3. And 3 plus 2 is 5. So I think this is a 5. Okay. To do the same thing with the last column. Okay. -3 times row 1, -2. So that would give me +6. +6 plus 9 is 15. Now the good thing is my professors drilled it into write what you're doing, because you might have to go back. You never know. And it's easy when you're learning this. It's easy to make mistakes. When I do it, even when I'm by myself, I still write those row 1 plus row 2. I write it all out, okay? I highly suggest you do it too, because you'll forget it. Okay, now, we're trying to get, look at what our goal is. I'm trying to get this to be a 1. Right now I have it as a 5. Okay. How can I get that 5 to turn into a 1? Well, I could divide by 5. So I'm going to do 1/5 row 2 becomes row 2. Okay. And that's easy enough with these numbers. Row 1 does not change in this step. And that's 0, 1, and I guess that would be 3. Almost done. We want, in the end, this to be a 0. And right now it's a -1. So we need to come up with some way to manipulate this 1 to make that a 0. That's the idea. And the way I'll do it is I'll just add them. I'm just going to add them because they're equal and opposites. So row 2, whoops, I don't want vanishing pen anymore. Row 2 plus row 1 becomes row 1. So I'm going to rewrite row 2 because it does not change in this step. Row 2 plus row 1. So that's 0 plus 1. No change. 1 plus -1. 0. That was by design. 3 plus -2. 1. And there's my answer. My answer is x equals 1, y equals 3, or x1 equals 1, x2 equals 3. So there's my answer. But the last column of the augmented matrix gives you your solution to the system. So this is how you do it with matrices, okay? But this is the same thing. All day we've been dealing with 2 equations, 2 unknowns. And that's the same thing. It's the same thing. So it's 2 equations, 2 unknowns, and there you have it. You could, now with this, I mean, the computer doesn't know, you could still use substitution. You could still use elimination method. But this is one more technique in your toolbox. The thing about this is we're using this practice for future problems. And we need matrices to do more advanced problems like we'll see next week. Next week will be in matrix world. That's the idea. Okay, so let me make sure I got a picture of this. Clear it. And I know there's a couple problems at the end I wanted to look at. Let's look at 19. Is this the one? That's pretty much the same thing as what we just did. Was it this one? That is not the same thing as what we just did. So we should do 18. And I think we need to do 20 as well. Yeah. So we'll finish 20 at the end. Sorry. There's no way for me to flip. Oh, Jack. Where were we? 17? Jack's got a question. How do we determine our goal for rows 1, 2 to be 1, 0, respectively? So how did we? Are you asking how did I know that was my goal? I'm trying to solve for. Remember where this is coming from. You have x1, x2. So this means x1 equals that number. That's the idea. x2 equals that number. So this is coming out as x1 equals this number. x2 equals this number. That's the idea. So 1x equals this number. That is to say, 1x equals that number. 1y equals this number. That's yes.
Why is it 1 0 0?
If you turn that back into, let's turn this back into equation. So that's, what is that? x1 plus 0 x2 equals, and we found that equaled 1. That's what the line is. That's what the equation is. So we entered in 3, 2, 9, and we got out 1, 0, 1. So I think x1 equals 1. Does that make sense? So if you go back to lines, what does this line tell us? It says 1x equals 1. 1x equals 1. 1y equals 3. You don't want 3 y's equals 9. You just want 1y equals the number. So that's the idea. Does that make sense? Kind of, sort of. So look where it came from. It came from these lines. 3x plus 2y equals 9. We entered in just the numbers because that's all we care about. We know it's x1, x2. We did all of our process to get it going, and then it's outputting. This is the x1, this is the x2. That's the idea. Okay, and also you've been staring at math problems for too long. So there's that too. It's like if we would have started with this, even it's mind numbing. I can't imagine how dull this is. I can't. Okay, it goes really, really fast if you're the one doing it, but I can't imagine. So I will say, if you ever watch the video, you can adjust the speed. You can go twice as fast. I have to do that myself. Maybe I'm a little scatterbrained, but if I have to watch these lectures, I have to go twice as fast. I get bored too. I am only human after all. All right, let's see. I only have 4 minutes. So what did I want to say about 18? 18, it turns out we have infinite amount of solutions, and it's really all I can say with my time. I do apologize, but with my time, it turned out these are the same line. So I have to write one in terms of the other. So I had to do one in terms of the other. Okay. So I don't have full amount of time because I do want to show 20 as best I can, but infinite amount of solutions. It turned out they were the same line. That's what it turns out to be. You can kind of see that 8, -12, 2, and 3, 2, and -3. You can kind of see it ends up they're the same line, so they intersect infinitely. That's the idea. And so you have to write them one variable in terms of the other. So at least you get a warning that that's going to come up in 18. 20, I want to show because it says to use a calculator, and I haven't really used a calculator other than just one time I did some basic subtraction because I was getting tired. Let's see, if you have a graphing calculator, great. If you don't, you could always use Desmos for your homework. That's great. Highly suggest it. But part of it is to kind of show you with the calculator. So I think I have it set up where it's going to work. We'll see. I don't know. I've never shown it like this before. So is this on? No. It might not even work.
One is in the bottom.
I didn't think it was that. There it is. Okay, let's turn it on. Here we go. Maybe. Enter. Hello. Wake up. On. on. Wake up. Else. I think we got some. All right. Maybe. All right. Let's try to solve this matrix using the bracket. Okay. They're all different. Here on screen, I have a TI-83. This takes me back to my high school days. Here I have a TI-84. I have a TI-89 at home. They all can do this, by the way. They all can do this, but it's kind of cool. And here we have a digital one. So we got to find where the matrix is, and it's the second button and then matrix. I think I have anything else. Now I'm in matrix manipulation. I want to edit. Edit. Okay. Enter. Enter. Okay. Now, what matrix do I want? I want to enter in 0.4, 4.06, 5, 2.5, 6.493. That's what I want to do. And then I want it to do all the solving and arithmetic for me. That's what I want. So that is 2 rows, 3 columns. I wanted to. I want 2, enter 3. 2 by 3. There we go. All right, next step, I want to enter in that matrix. So I'm going to do 0.4, enter 4.06, enter 5, enter 2.5, enter 6.49, enter 3. All right, now I have my matrix as A in the calculator. It's in there. But I got to do something with that calculator. Okay. I want the calculator to do all the arithmetic for me and just spit out the answer. So the next thing to do, I want to go to the, I guess I want to call it home screen, but that's probably just a modern term. So let's go here and we want to find reduced row echelon form, RREF. So let's go to second matrix. Scooch over to math. We want to find the RR. There it is. That's reduced row echelon form. That's where it's fully reduced. That's what we were doing. I'm asking, do all the arithmetic for me. Okay, so do that. Enter. And then what matrix do we want it to work on? I want it to one I just entered. There we go. And it outputs the answer. Okay, so there it is. That's one version. All right, the Casio version of this calculator does it. All the TIs, all the graphing calculators, they all do it. It's kind of nice, but you know, I have a graphing calculator app on my phone. I think it was like $2, something like that. And then you can also just use desktop. That's true too. But my boss wanted me to show this, so I did. Okay, and then now you can see where the answer is coming from. It said round to the nearest 4 decimals, and so you can see where that comes from. So there you go. But I also showed you how you can do it by hand. That's how I solved it initially. So that's how I do it. But I'm supposed to show the graphing calculator, so have it. All right, let's see what time it is. I'm over on time, so I apologize, but it was the first day, and so hang out. If you have any questions, email me. If you have any questions, I'll see you next Tuesday and get those 4 things done. Homework A, quiz A, homework B, quiz B. All right. Let me know if you have any questions. I'll see you next week.
Thank you.